I'm Eric Williams. I am a professor here at the Golisano Institute for Sustainability. And in the spirit of this webinar series, the idea here is that I'm going to explain, talk about the big picture of sustainability and the research, how I see this research fitting into the larger sustainability picture. So first, if anyone who comes to our department or another sustainability department, one of the things that one starts with is a definition of sustainability. And this is the classic definition that many places start with. And this is from a United Nations group in 1983, and they define sustainable development or sustainability as follows. Sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And this is, I certainly don't have time here to get into sort of the influence of this on society since then. And so I think this is a very good definition. But on the other hand, if you look, let's look back at hunter-gatherers. And this picture is showing a bunch of hunter-gatherers going after some elk, I think. And this was, in some sense of the word, this is a sustainable society in the sense that it can continue for many generations, and one generation's activities do not negatively affect unduly future generations. But on the other hand, these guys are not going to write the next hit Broadway musical. And so this leads into my personal definition of sustainability. And that is what is really exciting about humans, about us, is not that there's a lot of us and that we are so good at keeping us a lot of us. It was rather this capacity of humans to discover and create cool things. And I think really we want to continue this grand human experiment. So I put those three figures there. One is the one on the left. That is the theory of relativity. The one in the middle is Starry Night, of course. And the one on the right is a bowl of ramen, which is another great human creation. And so we need to continue this experiment. We need fairly large societies with reasonable standard of living to give people the luxury of time and resources to continue thinking and creating. So now we're gonna, that's the forest, that's the very biggest picture. Now we're gonna start narrowing down as we go through the presentation. And so sustainability is very broad. And so next level of less broad is I focus on energy and energy and its relationship with sustainability. And why is energy so important? So modern economies and lifestyles require lots of energy. And also the way that we currently create and transform energy, including climate change, air pollution. If you've ever seen a picture of Beijing and the foggy air there, that's from the air pollution. That's an illustration of an impact of energy. The picture on the left is emissions from smokestacks, coal plants, and the emission on the right is, I think that's probably the world record biggest number of lanes for a toll booth, and this is in China. But not only Beijing, all over the world, megacities are dealing with congestion and air pollution associated with vehicles. And so clearly there are, we have to continue creating enough energy that's economical. At the same time, we need to reduce its resolve its environmental issues. So as a researcher, big challenge, what kinds of things, big picture, can one do to try to address that challenge? And so there are two broad categories of activities. One is develop new or better technologies. So go into the lab. The smiling guy up on the upper left is working in a lab on flexible solar panels. The middle picture, that's a Google Nest thermostat, which is a smart thermostat that you can connect with the internet and it learns your thermostat preferences. That's an example of a new technology that can reduce energy consumption and contribute to sustainability. So some researchers are in the lab developing these technologies. That's not me, there's another category of people who do research that I put in bold, is to inform societal decisions on energy. And so what might that mean? So moving on, before talking about how one might help inform societal decisions on energy, this is a slide that reviews some of the societal decisions that we're making on energy that maybe not everyone is familiar with. And so federal, state, and local governments are very active to manage energy in a lot of ways. So one set of things we do is to use government funds to support energy technologies financially. So for example, if you were to go to a car dealer and buy a electric or a plug-in hybrid electric car, you could deduct $7,500 from your tax bill next year. So this is the government gets less tax. So essentially, the government is giving money to promote the development of these technologies. There's another set of activities are voluntary. So if in the United States, I guess probably I see all the audiences from the United States, if you've gone to Best Buy and looked at appliances, you might have seen one of these yellow energy guide labels inside a dishwasher or washing machine. And these labels it's a federal program, actually, and it's the Department of Energy in cooperation with the Federal Trade Commission, and they arrange for these labels to be put in on basically all the appliances that are for sale to let consumers know about the relative energy consumption and also the utility bills that you're going to pay if you were to purchase that appliance. And that's supposed to help encourage consumers to buy more efficient appliances. We also have many laws related to energy. There's all kinds of, New York State, for example, we have the New York state legislature has decided a schedule for adoption of renewable energy technologies. And so then it's up to utilities and to make sure that we're building up more wind and solar over the next couple of decades to meet those targets. So lots and lots of things that the government is doing to manage energy. So why is there a need for research to help this process? And it's actually hard to figure out what the right policies ought to be. So there are a number of challenges. And one of the challenges is that technology keeps changing. And as technology changes, what is the best decision also changes. The other is that people's use of technology. Will they buy an electric vehicle or not? Will they put a solar roof on their house or not? What will they set their thermostat settings in their house? How people use technology also changes, which complicates the equation. And then you have all these factors interact. The technology, people's behavior, economics, they all come together and interact and make it hard often to predict what the effect of a given policy will be. And so these are some of the challenges that research can help with. So to expand a bit on the technologies evolving point, if you look at the upper left-hand side, you'll see a graph that says solar PV global production and cost per watt. And that y-axis, the blue line, is the cost of solar, and then the x-axis is years starting from 1980 going to 2008. That's kind of an old graph, but the trend is still continuing today. The main thing to take home there is that the price of solar panels has been falling rapidly for decades, and it's still continuing to fall. And so, although solar panel power is currently still more expensive than the ways we more often produce energy, such as coal power and natural gas, there is potential, there's promise that it will continue to get more inexpensive so that it actually becomes competitive with those technologies. And so many of the government programs are designed to try to help these technologies develop so that they will become competitive broadly. And then on the bottom row, I'm showing the evolution of the computer from an early, I think that's a early K-Pro computer to a modern Microsoft Surface. And information technology has changed so much and affected our lives, and also gives us new tools to manage our energy use, that it's changing and it's very relevant to energy. So to a bit more in the technology's changing point, you see the person here in the lower left-hand corner holding an iPad. That's a Netflix display. And so this is the reason I put that figure there is it's illustrating that how we spend our time and where we spend our time is changing. I'll talk more about this later. But where 20 or 30 years ago, if you wanted to see a film, you'd go to the movie theater or you'd drive to the video store and come back with one of these VH videos for the people in the office, in the audience old enough to remember there are these giant plastic boxes with the VHSs. That's all gone. So now if you want to see film, you still have movie theaters, fewer of them, but you just click on Netflix. And so this affects how much time we spend at home, how much drive we're doing, and which that in turn is important for energy use. So next, I hope I've persuaded you that there are important questions to understand with research to design energy policies. Now I'll go to the next layer down, which is the research to construct energy models. And so what I do, and a lot of other of my colleagues do, is construct energy models. And these are mathematical simulations or mathematical representations of a piece of the energy system that are designed to answer specific questions that are relevant to a decision. So for example, how cheap will wind power become? So the big turbines, if you've driven, in New York State, we have quite a few wind turbines. I've certainly seen quite a few driving out and about. These, depending on where you put them, can be very inexpensive, can lead to inexpensive generation of power, but still there's a lot of sites where it's still expensive compared to natural gas or coal. And so cheaper wind power would be very important, and it would be very interesting and relevant to know that, can we, through government policies, stimulate progress in these technologies so that they become cheaper, economically competitive broadly with natural gas and coal. Another kind of question you might make a mathematical model for is how much should we subsidize solar panels in order to persuade people to buy them? So the federal government actually has a 30% tax rebate on residential, on household solar panels. And so you can get 1/3 of that cost back when you buy it. Is that the right amount of subsidy that's going to persuade enough people to buy it to achieve the goals that we want? That's actually that's a hard question to answer, and there's still that people have certainly worked on it, but there's certainly more to understand. And third, how do changing lifestyles influence how much we use? This ties back to this Netflix question. If we're now going to the movie theater much less, and we're not driving to the video stores anymore, how has this changed how we're using vehicles? How many are we using building energy use? And so the kind of research that I do is to make these mathematical models to address these questions. So this is not the time or place to go into a great amount of detail in terms of how these models get built. So instead, I'm going to give a couple examples, and try to give you a flavor for the kind of model that it is and the kind of result that comes out. And so the first example I'd like to talk about is going back to this first question, which is trying to answer this question, which is how cheap will wind power become? And so the mathematical approach to try to answer this question is to examine the past. And so the idea is that if there is a regular pattern to how the technology has changed in the past, then if that pattern continues in the future, then you have some sense of where you think things are going. And so the first part of this becomes, can we have a mathematical sense of what describes the past? And so it turns out for the cost of energy technologies, that something called the experience curve works very well. And so if you look at this graph here, this is showing on the y-axis, this is the natural log. I didn't label it very well. That's actually, but I'll say it out loud here, and hopefully that's enough. So this is the cost of solar panels. And then the x-axis is the total, it's the logarithm of the total production. So essentially this is looking at the cost of solar cells versus their total production. And as you see, there's a fairly regular, these dots, and these dots are reflect the total production of solar cells in a given year. These more or less fall on a line. And since they fall on a line, this is a sense that there's a regular behavior in how the costs fall. And the regular behavior can be summarized like this. Every time we double the production of solar cells, we get a fixed percentage drop in their price. So let's say we start off, we built 1 unit of solar cells and the cost is $10. Then if we build 2, the second unit, the cost falls by 20% or down to $8. And then if we build up to 4 units, the cost falls to another 20% to $6 or so. So this relationship is called the experience curve, and it's very useful to it's an empirically robust description of past cost reductions. So, and that fixed share for each doubling is called a learning rate. And for solar cells, that learning rate is 20%. So what we did is that we built a model for the experience curve for wind power, looking at the past. To cut right to the chase, our result is that this percentage drop is about between 7.7 and 11%. So wind is getting cheaper, but not as fast as solar power is. So now, what about the future? And so we assume that these trends continue and extrapolate, which, as I've put in bolded, is an assumption. Now, if coal and natural gas prices also follow the forecast that people think is going to happen, which is assumption because the future is hard to forecast. But given if these two things are true, then wind power will become cheaper than natural gas and coal power by around 2025. So that's showing some promise. Next paper that I'd like to summarize is this getting back to this question of how changing lifestyles influence how much energy we use. And here the starting point of this is this observation that technological change affects lifestyles. So I mentioned before the Netflix effect, but if we also think about other parts of life, shopping, much of the shopping that we do now is not going to the store, but shopping online at Amazon and other vendors. Work, many of us now work from home or from coffee shops in my case, which we can do now because of computers and the internet. We presume this, given thinking about how much our lives have changed in the last couple of decades, this could have some pretty important effects on our energy consumption. And so in this work, what we're doing is we're using our time use as a way to measure how our lifestyles is changing. And what I mean by time use is looking at time diaries. And so the time diary is this. It's a record of what a person does from when they get up and in the morning and then go to bed at night. And so, for example, you get up at 6 a.m. and then maybe from 6 to 6:30 eat breakfast, and then from 6:30 to 7 get dressed. You could then have a sort of a string of numbers and and activities that describe that day, including traveling to work and coming back from work and going shopping. And so there's actually a lot of, the federal government actually spends a lot of money to collect that time diaries, the Bureau of Labor Statistics. And so they actually get time diaries from around 10,000 Americans every year. And so there's a whole lot of data that one can try to mine and utilize for various purposes. And in this case, to try to understand how technology is changing our lifestyles. And then we're also looking at how this affects energy use. So to go straight to the result, our results suggest that Americans are saving energy by staying at home. So let's walk through this. So first, you have information technology and other trends like the aging society. They go through and they change our lifestyle, and we measure that in terms of how much time people are spending in what location. And it turns out, and I thought this was really surprising, we found this very interesting, that it's huge changes. So if you look in 1 year, in 2013, Americans on average spent 7.8 days more at home in 2012 compared to 2003. So in 10 years, an additional 8 days in that year. So this is a huge shift away from moving about to staying at home. And so because it's only 24 hours in the day, if you're spending more time at home, you're spending less time somewhere else. And this turns out to be less time driving and less time spent in commercial buildings like stores and movie theaters and offices. So then we built an energy model to try to map these time use changes to changes in energy use. And the result is that the net effect is a reduction in energy use. And this is because if you think about what is the most energy intensive thing we do per minute, it's driving a car. And in America, people often get around by driving by car. And so any reductions in driving result in large energy reductions. And also, if you've driven around and seen the empty malls and the empty closed movie theaters, those are, I mean, they're sad to see because of the lost jobs. There is a silver lining, so to speak, in that those buildings aren't consuming energy anymore. And retail buildings do use a good chunk of energy. So on balance, we do use a bit more energy in the home, but that's more than counterbalanced by savings elsewhere. So two takeaway lessons from these papers are, one is that we win costs. There are some optimism, cause for optimism that the government programs to stimulate cost reductions will help out. The other is that if we're thinking about policies to reduce energy use, because people are spending more time at home, the policy that suggests that we ought to shift the policy focus to emphasize those things that people are doing more, improving the efficiency of homes, of appliances, and electronics. So to wrap up, going back to the forest, so we went down big picture, medium picture, and now we're going to go back big again. These kinds of models, so I've given a couple examples, but there's many more others. These kinds of models can help us understand trends to better plan ways to get to a more sustainable society. And that said, a model on itself isn't going to do anything. I mean, unless somebody makes a decision that is based on the information, it's just a paper on a shelf somewhere. So it's some combination of models and good models. That's another, reasonable, believable models and good politics that will lead to better decisions to help us manage the future.